in this session we will study about the differentiation. First I would like to define what is differentiation. Differentiation means the rate of change in one of the variable with respect to other variable. In other words, the rate of change in y with respect to x. Here you see in this figure. This is our x-axis, this is our y-axis, this is our variable, and this is our function. We have to differentiate this function. I take a point P, point P here, another point Q here on this function. Now I draw perpendicular from point P on x-axis this is our one perpendicular, and another perpendicular from point P from point Q on x-axis. So I give some name to these points. This is our A point and this is our P point. And we see the distance from O to A is x. This distance is x. And distance from A to B is h. So the distance from O to B is x plus h we have. Now we have to find out the distance of PA or AP with respect to x. So it is f of x, and QB would be, because this coordinate of this point is x plus h, so QB would be f of x plus h. Now I draw another perpendicular from point P on this perpendicular QB. Perpendicular, and I meet a line PQ. Point PQ I meet through a line like that here, and we see the angle between at this point. I give a name to this point where this perpendicular lie. So this is our M point we have, and we assume that this angle is theta we have. Now in this triangle P and Q, in triangle P and Q, angle M is 90 degree we have here. Angle M is 90 degree. This one is 90 degree, and angle P, which is theta. So with respect to this theta, QM is perpendicular and PM is base. So we find out tan theta is equal to QM over PM. So you know that tan theta is equal to QM is f of, we could write in this way, QM QB minus MB. It is QB and this one is MB. So we get QM here, and denominator that is PM. PM is equal to AB. So we can write AB. Now tan theta is equal to QB is f of x plus h. We know that the QB is f of x plus h. Yeah, we have seen that. F of x plus h minus MB. MB is equal to PA, which is f of x. So we put here f of x. over AB is h. But if we reduce, we coincide this Q point on P. Q approaches to P as h tends to 0. The B approaches to A and the h becomes 0. So we make the limit for this. Limit h tends to 0, then f of x plus h minus f of x over h. Because why we are doing this? Because if we draw a tangent on point P, it would be like this, and another tangent would be like this. We have to make the tangent, the unique tangent we have to make for this P and Q point. So the Q approaches to P as well as the B approaches to A, the H becomes 0. Then the tangent would be coincide, there would be a unique tangent if we have H approaches to 0. So here, so this is called the differentiation, dy over dx. The rate of change in y with respect to x. Rate of change in y with respect to x, the change rate of change. So here, this is a way to find out the differentiation. This is a formula for differentiation by first principle. Dy over dx is equal to limit h tends to 0 f of x plus h minus f of x over h. So this is our formula. Now we derive one or two questions regarding this differentiation. So we know that here I put one question for this. We have a y is equal to x power n. Now we have to find out dy over dx. So y is, it is also f of x, we could say. So f of x plus h is equal to x plus h power n. Now we put these values in this formula. So dy over dx is equal to limit h tends to 0. F of x plus h is x plus h power n minus x power n. F of x is x power n here. I have to put in this formula, and denominator there is h. Now we see here limit h tends to 0 f x plus h whole power n. So we use the binomial theorem here. So we get here n combination 0 x power n plus n combination 1 x power n minus 1 into h plus n combination 2 x power n minus 2 h square, and so on. At the last we get n combination n h power n, or here minus x power n is already there. In denominator there is h we have. So we get here limit h tends to 0, n combination 0 is 1 and x power n. So it is x power n, so we can cut it here. X power n, it is positive, this x power n is negative, so there is no need to write this one. So first we have remaining these all. I take h as a common from each of the term, because every term having h as a factor. So h I am taking outside here. So here n combination 1 x power n minus 1 plus n combination 2 x power n minus 2 h, because the 1 h we have taken outside here. And similarly at the last term n combination n h power n minus 1. So this we have. In the denominator we have already h over there. So what will happen? H and H will eliminate. Now we put the limit in this expressions. We get here n combination 1 x power n minus 1. The remaining elements, the remaining terms would be 0 because there is h. If you put instead of h 0, so you get all the terms 0. You have only n combination 1 x power n minus 1. It is there is no h in this term. H-less term is this. So we get here n combination 1 is n and x power n minus 1. This is the dy over dx for the function x power n. So in this way we could easily find out the differentiation of the functions.